Look at 7.5, solving rational equations. So first, what is a rational equation? A rational equation contains rational expression. We talked about that. It's a fraction with a polynomial. So it has to contain a rational expression. And the word equation means it has an equal sign. And when you have an equal sign, that means you can solve for your variables. So a really simple example would be 1 over t plus 3 equals 5. We have a rational expression, we have an equal sign, we could solve for t here. Okay, so when you're solving a rational equation, you're going to need to find the LCD, or the lowest common denominator. So just like when you have fractions, so just remind you, if I'm adding 1/2 plus 1/4, we need to find the LCD of these denominators before we can add them. We're going to do something similar, but we're going to be looking for the LCD so that we can get rid of our fractions so we can solve. So how do you find the LCD? The way I always mention it is, first thing that you need to do before you can even find the LCD is you need to factor if you can. So if you can pull out a GCF, if you have a trinomial you can factor, you need to do this first before looking for the LCD, so it's the least complicated LCD you can find. After you've factored, I always say go in this order. First look at your numbers and find the LCD of your numbers. So for example, if you have 2 and 4, your LCD would be 4. What's the number that 2 and 4 divide into? The first number 2 and 4 divide into evenly, and that would be 4. Then look at any variables you have that are by themselves, like an x or a y. No addition or subtraction sign, just your variables. And you always take the largest exponent of your variable. This is the only way you'll be able to cancel out your denominators, is if you take the largest exponent. And then you look for any factors you might have, and if they have that factor in common, you only have to count it once. So for a factor would be, example, x plus 2. So number, variables, factors. So let's practice finding the LCD before we even start solving. Okay, so we're going to find the LCD of the following. Let's start with 3x squared y and 9xy squared. So we first start with the number. So well, actually, first we start to see if there's anything I can factor or pull out, and there isn't. These are as simplified as they can be. So we're going to go in order and start with the numbers 3 and 9. The LCD of 3 and 9 is 9. That's the first number. Both 3 and 9 divide into evenly. Then we look at our variable. So we have an x squared and an x. The largest exponent is x squared. Okay. Then I have a y and a y squared, and the largest exponent is y squared. And then I don't have any factors, like an x plus 2. So that is my LCD. Okay, let's do the same thing with the second one, but before I can find the LCD, I have to take this x squared plus 6x and simplify it by pulling out the GCF of x. So I'm going to pull that out first, and that leaves me with an x plus 6. And now I'm going to ignore that. Okay, so I'm now finding the LCD of x plus 6 and x times x plus 6. What might help you is to put this x plus 6 in parentheses to write it that's a factor. It has to stay together. It's not, don't look at the x and the 6 separately. So first start with the number. The number in front of both of these is just 1. So if I needed to write that, I could, but we're going to have a variable. So we're going to skip to the variable. And the only variable by itself, there's no variable in front of this factor, but there's an x in front of the second one. And then they both have the factor x plus 6 in common, so I only need to count that once. So this would be the LCD. Okay, let's do the same thing with the second one. Again, first I need to simplify. So for 3x plus 3, I'm going to pull a 3 out. And I get 3 times x plus 1. And for the second one, I'm going to pull a 6 out, and I get 6 times x minus 1. And I'm going to ignore those two and just look at what I've factored. Now we're going to find the LCD, start with the numbers. So 3 and 6, the LCD of 3 and 6 is 6. It's the first number 3 and 6 divide into evenly. I have no variable by itself, so I go to the factors, and they're different, so I have to include both of them. So 6 times x plus 1 times x minus 1. That is my LCD. Okay, and for this last one, x minus 8, x minus 4, x squared minus 12x plus 32. Let's factor the x squared minus 12x plus 32. And that factors. Again, always use your other denominators to help you, or your other factors. And in this case, it actually is both of them that works. X minus 8 times x minus 4. The negative 8, negative 4 multiplies to be positive 32 and adds to be negative 12. So when I go to find the LCD, there's only numbers 1. There's no variable by itself, and then all I have is the factors. And they have them in common, so x minus 8, x minus 4. So that's the LCD. Okay, so I'm going to show you how to solve a rational equation. And the first thing that you need to do is multiply all terms. So you can't leave a term out. It's the only way it stays an equivalent equation, by the LCD over 1. And when you do that, it'll get rid of fractions. Okay, so multiply everything by that LCD you're going to find over 1 and get rid of all the fractions. That'll make solving much easier. And I'll show you this in just a minute. Once you do that, when you've solved, you always need to check your solutions. This is really important, to make sure your denominator does not equal 0. Because remember, we said if your denominator is 0, that's undefined. So you need to eliminate any of these extraneous solutions if you get something that makes your denominator 0. So for example, if you're doing the homework and you get 2 answers, 2 and negative 4, let's say, and MyMathLab keeps saying it's wrong, check to see if one of them makes your denominator 0, and then you need to eliminate that one and just put in the 1 answer. Okay, so let's practice solving. We're going to solve 1 over x squared plus 2x plus x minus 1 over x equals 1. So before I can even solve, the first thing I need to do is simplify this denominator, x squared plus 2x, before I try and find the LCD. So what I'm going to do is pull out that GCF of x and rewrite this as x times x plus 2. If I don't do this, my LCD is going to be much more complicated and it's going to be much harder to solve. So you always want to do this first. Equals 1. Okay, then let's come up here and write our LCD. So at first, think of this one here as 1 over 1. So I'm the number 1. I'm not going to have to really worry about the LCD here. So let's look at these two denominators. There's the number 1 in front of them. So let's go on to the variable. And they both have an x, so that's the largest exponent. And then there's the factor x plus 2. So that's the LCD, x times x plus 2. So the directions say we want to multiply everything by the LCD over 1. As long as you multiply all 3 terms by this, you're okay. I actually need to leave a little room here in order to be able to write this multiplication. So let's redo this and put equals 1 over here. So leave a little gap. And now I'm going to multiply everything by the LCD over 1. And it's important to write this so you don't accidentally leave something else. So x times x plus 2 over 1 next to each term. And since this is just a 1, I'm not going to, it's not a fraction, it's not written in fraction form, I'm just going to write this as x times x plus 2 and not put it over 1. Only do that when you're dealing with fractions like this. Okay, and then this is just like multiplication that you did in 7.2. Let's cancel any like terms. So in this first one, I can cancel the x's and the x plus 2's. And that just leaves me with 1. Over here you can cancel the x's, and that leaves you with x minus 1 times x plus 2 equals, on the right hand side nothing cancels, so I have x times x plus 2. Okay, so now we need to solve. So I'm going to FOIL the x minus 1 times x plus 2, and I'm going to have 1 plus x squared plus 2x minus x minus 2 equals, and on the right hand side I'm going to distribute the x, and I have x squared plus 2x. Let's combine our like terms. So we have a 2x minus x and a 1 minus 2. And when I do that, I get x squared plus x minus 1 equals x squared plus 2x. And this looks like it's going to be a quadratic that I'm going to have to solve, but when I subtract x squared from both sides to start solving or combining like terms, notice that both of them cancel out. I'm going to move over here now. And when both of them cancel out, I'm left with x minus 1 equals 2x, and this becomes a lot simpler to solve. Okay, so now to get combine our x terms, let's subtract x from both sides. And we get negative 1 equals x. So we've solved. Now before I show this as my answer, I need to go up and check. And the way that you're checking is you're looking at your denominators here. And you're seeing if I plug in negative 1 for x, would either of these denominators become 0? And here you'd have 1 minus 2, that's not 0, and over here you'd have negative 1. So you just need to check, go back and look, make sure it's not 0. If it's not 0, then you can say this is a solution. So x is negative 1. Okay, so let's try another one. In this case, we have 3 over a plus 2 equals a minus 2, a plus 3 minus 1. And there's nothing to factor here, so I can go right to looking at what is my LCD. My denominators are in simplest form. So if I look at my denominators, I basically have a plus 2 and a plus 3. There's no there's the number 1 in front, but there's no other number. There's no variable by itself. So I just have my two factors of a plus 2 and a plus 3. So that's my LCD. So I need to multiply all three terms by that LCD over 1. So over here, I'm going to multiply by a plus 2, a plus 3 over 1. I'm going to multiply this one. It's going to be a little squishy. And then you also have to multiply this minus 1, so don't forget this term as well. All three terms need to be multiplied. Okay, so let's start with anything we can cancel. With the first terms, the a plus 2's can cancel. And I have 3 times a plus 3. Let me fix that a. Okay, equals, with this term, the a plus 3's cancel, and I'm left with a minus 2, make sure you put that in parentheses, times a plus 2. So you're going to need to FOIL that out. Minus 1 times a plus 2, a plus 3, which is basically just a plus 2 times a plus 3. You are going to need to be careful with the negative sign though. Okay, so let's go ahead and simplify. First thing I'm going to do is distribute that 3 through the parentheses, and I get 3a plus 9 equals, on the right-hand side of the equal sign, a minus 2 times a plus 2, these are conjugates, which means when I go to FOIL this, my outside term, which is a positive 2a, and my inside term, which is a negative 2a, they cancel out. That's 0, 2a minus 2a, 0. So I really only need to multiply my first and my last terms. So a times a is a squared, negative 2 times 2 is negative 4. Minus, now put all this in parentheses when you FOIL it, because you need to not forget that you need to distribute this negative sign. So I'm going to FOIL a plus 2, a plus 3, and I get a squared plus 3a plus 2a plus 6. Okay, so let's simplify. 3a plus 9 equals a squared minus 4 minus, I'm going to combine the 3a and 2a. Okay, and now I'm going to go ahead and distribute that negative sign through the parentheses. So we have 3a plus 9 equals a squared minus 4, I'm going to just change every sign here, minus a squared minus 5a minus 6. Now you look at our like terms on the right-hand side, and we have both an a squared that we can, and a negative a squared. Just change this so that we can cancel this a squared and this negative a squared. And now I'm going to combine my negative 4 minus 6. So let's rewrite this. 3a plus 9 equals negative 5a minus 10. Negative 4 minus 6 is negative 10. Okay, let's start combining our like terms. So I'm going to add 5a to both sides of the equal sign. And at the same time, I'm going to subtract 9 from both sides of the equal sign. And that way these will cancel. And when I do this, I'm left with, I'm going to come over here, 8a equals negative 19. Divide both sides by 8, and you get a equals negative 19 over 8. And then just check if you're putting an answer like this in MyMathLab, do they want it as an improper fraction like this or as a mixed number? Now remember, I just need to go back and check and make sure this doesn't make my denominator equal 0. And if I look at my original denominators, a plus 2 and a plus 3, if I plug in negative 19/8, neither one of these would be 0. There's no way negative 19/8 plus 2 would be 0. So this checks, it's okay. We'll just put a check mark to show I've checked it. Okay, let's look at a work problem, which will have a rational equation in it once we're done setting it up. So a work problem is when you have two different rates working together, and you want to see how long it'll take them working together. And so in this case, Joe is trying to fill his tank at his farm. He has 2 wells. The less powerful can fill his tank in 10 hours, and the more powerful is faster. It only takes 6 hours. How long will it take both pumps working together? So first of all, you should always check when you're solving one of these when you get your answer. Does your answer make sense? If one takes 10 and the other one takes 6, working together, it should be less than this lowest amount, 6 hours, because it should be much faster, they're working together. So there's different ways to set this up, and if you look on MyMathLab, you might see a different way to solve it. So you can solve it any way that works for you. I'm going to show you one way. And the way I do this is I look for how much they complete in 1 hour. So I'm going to start with the less powerful. If it takes 10 hours, how much has it completed in 1 hour? And that would be, it has completed 1/10 of the work. Then for the more powerful, if it takes 6 hours, how much has it completed in 1 hour? And that would be 1/6. And then I want them to be working together. And let's call the time it takes them together. We don't know what that is. Let's call it t. So I want to know if this 1/10 works together with the 1/6, so their time together. How much will they complete together in 1 hour? Well, I don't know how long it takes them working together, but I do know in 1 hour they will have completed 1/t of the amount of work. So this is the equation that I'm going to solve. Okay, so the first thing you need to do is, just like we did before, is find the LCD and multiply everything by the LCD over 1. And the LCD of 10 and 6 is 30, and then your variable is t. So the LCD is 30t. I'm going to multiply all three terms by 30t over 1. And then I'm going to go ahead and simplify this. And when I do that, 30t over 10, 30 divided by 10 is 3, so I get 3t, plus 30 divided by 6 is 5, so 5t equals, on the right-hand side of the equal sign, the t's cancel, and I just get 30. And this becomes actually really simple to solve now. 3t plus 5t is 8t equals 30. Divide both sides by 8, and you get t equals 30 over 8. And because this is a word problem, I want to convert this to a mixed number or a decimal. Again, MyMathLab, just see what they ask you to write your answer as. This would be 3 3/4 or 3.75 hours. Make sure you include units for a word problem. So it'll take almost 4 hours, 3 3/4 hours for them working together. And that answer makes sense based on the fact that the fastest one takes 6 hours. So our answer should be less than 6 hours. You should highlight this problem because I see that this one gets forgotten a lot on tests, and it's really, once you set it up, pretty easy to solve. So just think of how much you complete in an hour separately and then working together. Okay, so now we're going to look at a motion problem. Let's set this up. We're looking at a distance, rate, time problem. So distance equals rate times time. And whenever I'm solving a problem like this, I like to put a table to kind of organize my information. So this is something you could have in front of you to kind of remind you, distance equals rate times time. Let's fill in the information we're given. So it says a motorboat travels 20 miles per hour in still water. If the boat travels 62 miles upstream in the same time it takes to travel 98 miles downstream, then what is the rate of the current? So this is what I'm trying to find, the rate of the current. And I know that we're talking about the same time, and I'll come back to that in a little bit. So the first thing, let's fill in our information. We know the distance upstream is 62, and the distance downstream is 98. I don't know the rate of the current, but I know upstream, so you're going against the current, which means you're going to go slower. That's why they traveled less distance, is going to be the rate in still water minus that current. So kind of like a plane. If you're traveling east, a lot of times it's faster because the wind's pushing you faster, and then if you're going west, it's pushing against you, so the flight takes a little bit longer. Same idea here. Downstream, it's going with the current, so it's going to be 20 miles per hour plus the current. It's going to push it a little faster. And then I don't know the exact time. I do know it took the same time, but I'm just going to call this T upstream and T downstream. But these are actually the same times. I do know that. Okay, once I filled in my table, I'm actually just going to write my two equations. 62 equals 20 minus r, put that in parentheses, times time. And then 98 equals 20 plus r times time. So I just took what was in the table, distance equals rate times time, and I'm just rewriting it. down below. Okay, I know that they travel in the same time, so I actually want to solve for time. So I'm going to go to this first equation. To get time by itself, I'm going to divide both sides by 20 minus r. So the time upstream would be 62 divided by 20 minus r. I'm going to do the same thing over here. The time downstream would be 98 over 20 plus r. Now the same time means that this time is equal to this time. So I can actually set the 62 over 20 minus r equal to the 98 over 20 plus r. I'm going to go to a new page and do that, give myself a little bit of room to solve. Okay, so I'm not going to be able to get rid of that right now. So let's go ahead and rewrite our two equations. So we had, if I can, 62 over 20 minus r equals 98 over 20 plus r. Now to solve this rational equation, I'm going to multiply by the LCD over 1. We could also just cross multiply here, which would give us the same answer and work out exactly the same. And we're going to do that in the next lesson. But right now I'm going to multiply by the LCD over 1. And in this case, it's just both factors, 20 minus r, 20 plus r. So we just have two factors. We don't have any variable by itself or a number outside of these factors. So this becomes pretty easy. The 20 minus r's cancel. And I'm going to have 62 times 20 plus r equals, on the right-hand side, I'm going to have 98 times 20 minus r. I'm now going to distribute the 62 through the parentheses. I get 1240 plus 62r equals, let's do the same thing with the 98, and I get 1960 minus 98r. Okay, we now want to combine our like terms, so I'm going to add 98r to both sides, and at the same time I'm going to subtract 1240 from both sides. The 98r's will cancel, the 1240's will cancel, and when you do that, you're left with, let me come over here, 160r equals 720. Divide both sides by 160 and you get 4.5 miles per hour. So the rate of the current is 4.5 miles per hour.